This is the second part of a journey that started yesterday in terms of considering potential roads or potential pathways to conscious experience. Yesterday we heard about global neuronal workspace theory, predictive coding, and quantum approaches to consciousness. And today we're going to be hearing about integrated information, higher order theories, and then also a final synthesis and consideration of these various theories. So we're going to start off hearing about integrated information theory from Dr. Naotsugu Tsuchiya, who received his PhD at Caltech under the mentorship of Christoph Koch. And the work from his PhD was actually recognized with the William James Award at the ASSC. He then did a postdoctoral fellowship at Caltech. He was in Japan, and now he is an associate professor of psychological sciences at Monash University in Melbourne, Australia. His primary interests are in non-conscious processes, the relationship between consciousness and attention, and integrated information, and that's what he'll be speaking on today. So please join me in welcoming him.
Thanks for your kind introduction, George. I'm honored to be here and then give a talk about this integrated information theory. So the title of my talk in the program is Theoretical Characterization and Empirical Testing of Integrated Information Theory of Consciousness. But what I'm going to try to tell you today is this: what it is like to be a bat. That's a famous question in philosophy. And I think IIT could be possibly only the way to get to the question. And I try to persuade you how it could be the case. So just before my talk, one announcement. I'm in collaboration with Ryota Kanai looking for a postdoc on a project to test IIT. So if you're interested, please contact me or Ryota later. And before the actual contents, I want to introduce the key collaborators. And Andrew here is most of the guy who did the most of the work on the empirical testing. And Masafumi Oizumi is the theorist who developed lots of nice tools for the empirical test of the IIT. And he's also the first author for recent IIT paper with Tononi, so you might have heard of name Oizumi. So the talk overview is the following. First, I'll introduce the question of what it's like to be a bat, and then I'll discuss also is it possible that this kind of question is possible to address, and then I'll give you a very intuitive understanding of IIT, and I'll explain how we can actually empirically compute it, and then towards the end, I'll mention my recent research on empirical testing of IIT, and then coming back to the BAT program. So here's Thomas Nagel, who wrote a paper in 1974, really asking this question: what it's like to be a bat. It's not like what do you feel? How can you imagine what the bat is feeling like? It's more like, if you become like a bat, like this, what it is really, the experience of the bat, himself. And you can't really report on that, after coming back to human or anything. You just need to think about, need to be a bat to feel this. So as George reviewed, we have seen several pathways to consciousness: global workspace, or predict coding, or quantum brain, or higher order theory, which you'll hear next. And also, which is one of the things that is missing is the search for the neuronal correlates of consciousness, like a gamma oscillation, a coherence, or a P3B wave, and things like that. But none of them, I would say, ever gets too close to the answer or any, I can't really imagine any possible approach to get to the question of what it is feeling, like bad, actually. But IIT, I think it's possible to approach this question. And the key question for me is that following: why does visual experience feels like always, kind of visual experience. And it's always the case that any visual experience is some definitive phenomenal structure that is very similar to any other visual experience, which is very different from auditory experience. So you can always distinguish, oh, this is vision, this is audition. This is so obvious and easy. And in terms of BAT question, I think if we can address the question like, if BAT's echolocation similar to visual experience or auditory experience or non-conscious experience, like it doesn't feel anything to be a BAT using the echolocation, like our computation at cerebellum. If we can distinguish these things with a very educated, highly educated guess, then it's a really huge progress in the consciousness research. And that's the thing that I'm expecting from IIT. So I don't think it's a stupid question to ask this in BAT's experience. It's really a good question, which is a rare occasion of the philosopher's contribution to consciousness science, I think. But nobody really cares at the moment. But I think it's a really critical question. And but this kind of thing, which is not directly verifiable with the current science, it's not always stupid to ask. Like age of the universe, currently the most accurate estimate is 14.6 or 14.3. I don't remember that. Sorry, billion years. And this kind of estimate is now within the error margin of 1%. And most of the theorists actually agree with this error margin. And if you ask, who among yourself knows your partners or mothers or fathers age within the error margin of 1%, it's really very good estimate, right? I can't actually address this question, but other things like direct evidence of the evolution, because we haven't actually seen how the things evolved over the time. We can't directly, prove anything about evolution, but all the, biochemical laws and things, like, radiation based in age estimation and things like that, that all make sense to explain what we know about evolution and the age of the universe right now. And we can make some kind of testable predictions. So these kind of things which you can't directly verify can be still a very useful question to ask to promote the science. And I think the BAT experience is one kind of the question. So now I'm going to introduce integrated information theory, IIT. IIT is different from other types of the consciousness theory because it starts from taking phenomenology seriously and then try to extract or identify several properties of the phenomenal consciousness, which is true across any time of the phenomenal consciousness. And according to Tononi, which you might disagree, it is existence and composition. Composition means that things are composed of many different features, and then information, integration, and exclusion. I'll mention this, I explain this later. And then after identifying these key properties or axioms of the phenomenology, Tononi proposes what kind of potential physical mechanism can support these kind of properties. And that's how IIT goes. So this direction, usually neuroscientists goes from the observing the brain and then wonder how this kind of neuronal activity gives rise to consciousness. IIT is different. First, taking the phenomenology seriously and then go back to seek for neuronal mechanism. That's one key difference. And then about the existence, it is critical to realize that the phenomenology exists only for the subject, experiencing subjects. Like dreams or imagery or hallucinations, we can always experience things without any output, sensory inputs. And also we can experience dreams without sensory motor output as well. And then bistable stimuli like this can be actually, flipped and perceived without, any sensory perturbation, and it's all determined by the internal dynamics. That's what it means to exist intrinsically. And then informativeness in IIT means that each moment of experience is highly informative or unique, so that you don't really mistake one moment of experience with other possible experiences. Like right now, you're hearing my voice and then seeing myself or slides, hopefully not sleeping or typing on the a cell phone. But that excludes all the possibilities that you're staying at the hotel or going to the desert or something like that. So it's highly informative in that sense. And then integration and the composition aspect of the phenomenology is that experience is always composed of the various aspects like vision, audition, and within vision, color, shape, and things like that. And also always integrated and experience as a whole. You can't experience by attention or anything, just audition or just vision or just color or just shape. It's always one and at the same time. And so, according to this phenomenological property, IIT proposes several possible mechanisms that explains this phenomenological property. And I'll explain later how it can be. But if you accept IIT, then there is a benefit. IIT gives lots of explanatory power about non-neurophysiological and also brain-mind relationship. For example, there is a very big mystery about our cerebellum. Cerebellum has 4 times more neurons than the cerebral cortex or thalamus. However, taking out the cerebellum doesn't really diminish our conscious experience, and the people can live without cerebellum, and it will impair language and motor performance, but it doesn't impair consciousness. And also input structure like retina or output structure like motor cortex can be completely out, but still you can experience the things. And according to this IIT framework, Tononi and Massimini actually created this so-called TMS EEG paradigm, where they provided some kind of magnetic stimulation to the brain and then record the complexity of the evoked response in the brain using EEG. And then by quantifying the degree of complexity, they now have the probably currently known best performing discriminator paradigm called PCI, Perturbational Complexity Index, that distinguishes between the awakefulness from non-REM sleep or 3 different kinds of anesthesia, as well as brain damaged people like vegetative versus minimally conscious state people. So this is one of the most promising index for the level of consciousness. And even though this kind of explanatory power and also predictive power of the IIT, many people actually really hate IIT, and some people really dislike. Like maybe some of the people who are not here didn't come because they don't like IIT. But I try to address these questions, complaints. First, common complaints about IIT is that the IIT is all about the level of consciousness, and I'm interested in the quality of consciousness. So it's nothing to do with my interest. And the second common complaint is that it's so difficult to understand. If you read any of the Tononi's book or paper, it's full of mathematics and very difficult to understand. So that leads to some kind of misunderstanding, and then writing up some papers complaining IIT is impossible. And the third one is that even if you understand what IIT is saying, it becomes really clear. If you actually understand it, it's uncomputable and therefore untestable. Therefore, it's not a scientific theory, and so I really hate IIT. And then this is the same thing about no accessible papers available to give a student, for example. So if I try to teach IIT in the class, I can't teach. So I hate IIT. But I'm trying to write some kind of accessible essay right now, so this might be a bit solved in a year or so. Okay. And then my talk, specifically towards the end, tries to address some of these issues. One is to give the 2 intuitive explanations, different approach, so that it helps your understanding of what IIT is. And then I also try to give an empirical test so that you will feel like, IIT is not really untestable or uncomputable. And if you agree with that, then I'm successful today. So this first, I'll try to give an intuitive understanding of IIT in a nutshell, 2 or 3 minutes. So let's imagine 2 neurons that copies the state of each other. And the white means firing, and then black means not firing. So if this is one state of the system, which is the simplest thing that you can think, then it's a black, white, on, off, and then next moment it is white, white, black, and the next moment black, black, white again. It's just flickering at some time frequency. And then first key concept of IIT is how variable the system can be. And this system can be in the 4 possible states, both on, both off, or one on, one off, 2 types. So 4 types of the states. And that's quantified by entropy, concept of entropy. If you know logarithm, it is logarithm of base 2 and 4 gives you 2. And then the second key component is the intrinsic information. Without referring to anything outside of the world, IIT tries to compute how much the system knows about itself. So in this case, if the system knows that they are in this black-white state at time t, then one step before, it has to be white-black, according to this rule, right? That means that it reduced uncertainty about the past from 4 possible states into just 1 state. And that gives you this quantity called mutual information of 2. There was 2 uncertainty, and then now there is no uncertainty. So that's the intrinsic information. And then the third thing, which is key for integrated information, it is to consider this system separately by considering part at each time. And in this case, because all the action depends on the interaction between the 2 neurons, if you do not look at the other side of the neuron, and if you are only 1 neuron, you can't tell what the state was like in the 1 step before. So there is an ambiguity in the past. And same for the other guy as well. So here, the mutual information, considering a fictitious situation of no interaction between them, you get the mutual information star here, I star, equals 0. And then integrated information is the difference between the mutual information with the full information available minus cut information, 0 in this case. And so in this case, phi, integrated information, is 2 minus 0 means 2. Okay? And then, of course, this one, I'll just go on. Okay. And then now you can actually extend this type of analysis in many, many channels. Like in this case, if you have a 3-channel A, B, C, and then connected in some similar way, then you can compute this phi between A, B, as well as AC, as well as BC, and also 3 things at the same time. And the key is always mutual information about the past, using everything, versus cut version of the mutual information. And then the difference is the integrated information. And if you get that, then that describes completely the causal interaction within this system. Okay? Now, I give 2 notes. One is that all these key components, mutual information, entropy, and integrated information, all depends on the connectivity and also mechanism of the system plus state at a certain time. So if you, in other words, if you know the connectivity and the states of the system, IIT would predict a specific conscious percept in that system. So connectivity, it's, in other words, IIT claim that conscious experience is the function of the connectivity plus states. Okay. Then the second one is that, but we usually don't know the connectivity states or rules of the neural firing in the brain. So what we can do is actually either perturbation, like bringing some kind of stimulation and then see what happens, and that is actually a better way of characterizing the system's mechanism, or just observing how the things evolve over the time. Based on the stimulus or just a spontaneous activity. And these 2 things are the empirical approaches, and the second one, observational, is much more easier to do. And sort of a hybrid between the two is to give the different kind of stimulation, like visual stimulation, and then see how these 5 patterns actually evolve corresponding to the conscious experience. And that's what I'm gonna do in the end. So that's the first version of the intuitive understanding of IIT. Did you get it, more or less? Good, okay. And yes? H star is the conditional entropy. And that is the remaining uncertainty after knowing the current state. Thank you. Is there any more glaring questions? Fine. What? So integration is the lack. I'll actually explain it with another example, actually. But briefly, it is a loss of information after cutting the system virtually. Okay. So I'll come back to it later. Even if I explain this, without actually, playing around with the actual, MATLAB tools and so on, you can't really get it. So this is code that is available today. We made it available today. And if you go to the figshare.com and then type the keyword like phi toolbox or a practical phi or something like that, or always me, who is the first author, then you get the toolbox in zipped version. And this is MATLAB code, so if you're interested, please do it. And we can actually, with this toolbox, we can compute integrated information even with the continuous variables like EEG, MEG, and intracranial recording. That is what I'm going to talk about. So here, entropy is just, simply saying variability of the response. So if you have a EEG or MEG, and then if not every time you observe the exactly identical stimulus, then you can compute the entropy at some time point. And then the next step is the same, basically. Entropy minus entropy given observing current state. So there is some kind of a trick in mathematics, but you can compute that. And then finally, phi star, that is the quantity you can fictitiously compute. Again, this is a mathematical trick. But computing mutual information between past and the present minus cut version of the fake mutual information. And then if you apply that, then you can actually compute integrated information from the real data. Okay. So I'll give you 2 more intuitive explanation, and then I'll get a question after this. So first is that integrated information can be considered as a loss of predictability of the past states based on the current states when system is cut. Usually, if you talk about or think about emergent property or holistic thing, you try to think about what is additional, but it's the same as what is lost if you cut the things, and that's the way to think about it. So let's say think about brain state, and then try to decode how your past states. And then you can actually compute this decoding performance in many ways. We just use the mutual information, but decoding accuracy is also another possibility. And then you get the decoding performance with the whole brain or whole system, and then compare that with the cut system, just using a part of it and then decode. Cut system and then decode. And then if there is a loss of information, that means that the interaction is doing something that allows you to predict the past. And that is integrated information. One idea to interpret the integrated information. Secondly, integrated information can be, this is a new kind thing. We put it in the pre-server in the archive last year. Integrated information can be formally proved to be identical as a distance between the actual and the disconnected model. And this kind of framework gives you a better understanding of what the integrated information is with respect to different kinds of measurements. So what I mean by that, let's say you observe some kind of time series, and then you try to model or explain the model with some kind of equation. And then this goes from past to the present, past to the present. And then if there's 2 neurons, there can be in total 6 types of interaction. One is that, one neuron interacting with the second one at the same time, or with the lag, in itself, which is just a memory, or interacting to the other, and so on. And then if you compute the distance, abstract kind of concept of distance between the two models, and this full model versus disconnected model, that is phi, or integrated information. So if you know about the information geometry, this is a kind of equation, but I don't want to go into the detail. It's just important. If it's a Gaussian, if you assume a Gaussianity, then this phi g is very simple in notation and can be computable. And the added benefit of this kind of concept is that this allows you to situate integrated information here as a particular type of the disconnected model compared to other different kind of more familiar, hopefully, some familiar mathematician or computer scientist, which assumes a disconnected model. In the case of mutual information, there is no connection between present and the past. That's the mutual information. And then comparing that with a full model, and then distance, that is identical to a mutual information. Okay? And then transfer entropy from x1 to x2, y2, is just disconnected model, but only one connection cut. And then finally, stochastic interaction, or it's sometimes called Anil-Sess version of the phi, assumes the cut between the two interaction and also same time interaction here. And that's the difference between our version of integrated information and the Anil's version. And as a consequence, if you apply this geometric interpretation of the distance, it turns out that it's very simple and elegant kind of interpretation. So the location of the full model is here, Pxy. This is a real or best model that you can actually explain about this in data. And then the phi g is just a perpendicular projection onto this plane. And then this plane assumes that there is no connection between the two. And that's the all possible model space here. And just the distance between the real to the disconnected, and the minimum is the integrated information. On the other hand, mutual information lies in a much smaller dimension because it has a much severe restriction. You need to cut lots of connections between present and past, so the model flexibility is really reduced. And if you measure the distance, mutual information is always larger or equal to phi because it's far, always, farther than phi. And it's always above 0. And then again, coming back to Anil's version of the phi, it is again different dimension, which is also poor dimension compared to the phi. And so it is always farther than phi. However, unfortunately, because this has an additional constraint which was not present in the mutual information, it can actually exceed the value of mutual information. And we think that if you want to claim or integrated information, some kind of measure that exceeds information doesn't really make sense. In fact, our paper actually proves that this type of the measurement actually goes beyond much above 0, even if there is no information. And Max Tegmark recently wrote some paper, but basically he's also proposing this, and I don't think that's a good one, according to our criterion. So that's the two intuitive version of the IIT. And because I have only 8 minutes, I can't accept your questions. And let me go to the empirical test of IIT. So IIT's prediction about the contents of consciousness or quality of consciousness is that the patterns of the integrated information you compute across a system should be isomorphic or change when the contents of consciousness also change. It's one-to-one kind of mapping. So if there is such a thing between phenomenology and mathematical constructs derived by the theory, then I think that's the best we can do about consciousness. And also, it also dissolves the problem of the so-called hard problem, if we find such a one-to-one mapping. And then we will start with a very small system, but if you repeat this kind of tests in a huge number of different kind of paradigm and things like that, then we can probably make this theory more reliable and testable and also acceptable. And then eventually, we will test it in a no-report paradigm where we can also, assume some perception in a really accurate way. And then, even if that also, still, holds, then you can start to believe the prediction about bat's consciousness from IIT. So here's the real example. This is an intracranial recording from one patient where we were fortunate to implant the electrodes right onto the face area. And then this is a recorded response, and then you see the error bar, which means that there is a variability. So we can compute entropy, and then key here in entropy is that unlike other type of the measures you have seen, we compute entropy for all the combinations of 4 possible pairs of electrodes, A, B, C, D. From A, B, C, D, we have 6 A, B, or B, C pairs of the combinations, and the 4 trios, A, B, C, A, C, D, and things like that, and then 1 quartet, A, B, C, D. And then you can compute entropy. And the entropy is very boring. It's all just decreases after the stimulus onset. And same for the mutual information. It always decreases after stimulus onset. And then finally, integrated information. This now, things becomes very exciting. So if you look at that, some of the combination only increases or decreases integrated information at the time right after the stimulus is presented, and at the time period where we suspect that consciousness of the face emerges. And if I just present this one-time slice of the integrated information pattern across 11 subsets, then it looks like this. And then it's very difficult to present in 2D, so I'll make a 3D movie version. So here, I'm just looking at some kind of structure or shape of the so-called qualia, or phi structure, phi pattern from the above. And then now in the movie, I'm looking at from the side, and then rotate. And this, if IIT is correct and our approximation of IIT is more or less fine, then it is capturing some kind of quality of face experience. That's my claim. Okay, so in the case where we just present a different kind of stimulus, like upright face or inverted face or some kind of noisy Mondrian pattern, then we get this kind of different kind of patterns. And now I'm looking at the pattern from one particular direction. So always I look at the structure from one particular direction. Okay, so here you can see that something pops up on the top left. That's the kind of face property in this case. And then now in a completely different paradigm, which this subject just fortunately did backward masking. Then when the subject actually saw faces, there is some kind of peculiar pattern, shape coming close to top left overall. And then when the patient said that it was impossible to see or there was no face, then it kind of collapses or diminishes in amplitude over the wall. And then the key experiment was continuous flash suppression. Here, we held the stimulus completely constant, and then in each trial, we asked the subject to report how visible face was. So the physical stimulus is identical, but subjects report was variable across the trials. That is very similar to Stanley Haynes paradigm yesterday. And then when he actually saw face, then this face-like pattern emerged. And then when he said that he didn't see it, then it didn't. And then this is using the sort of threshold, most ambiguous cases. And then when we present a much more higher contrast, easy to see case, then here again, you see this face-related pattern as well. And then finally, when we use a much lower contrast face, then patients, phi structure, phi pattern became kind of collapsed. But still, when occasionally subjects said that oh, it was visible, then there is some kind of face-related property here. And then now, usually, most of these experiments are done separately within each, experiment. But if my claim is that, this pattern is general or capturing some kind of essential quality about the faceness, then it should be actually conserved across the paradigms, and that's what we try to capture here. So here, the left side is the visible trials in the backward masking experiment, And then here, the second one is visible trials in the CFS experiment. And the third one is in terms of stimulus, it is identical to the middle one, but the conscious report is very different from basically the subject denied seeing it. And I just should say that in left and right middle is very different in terms of task instruction or stimulus. Like phobia representation versus periphery, or reporting emotion versus not, and things like that. So, however, when we computed this, 5 patterns on the visible trials versus invisible trials, you see that these two are pretty similar. So, we want to say that this is really capturing really central quality of the conscious perception of face. And then when we try to compute this on a trial-by-trial basis, which is very difficult, mathematically, but we did. And then every time these red things there, this is according to the 5-based pattern. You see the non-conscious or invisible face trials falls here. And then across different three paradigms, when subjects see face, it's there. And then just for curiosity, when subjects saw houses or tools, it again clusters separately. So even though our claim is this, that this area is probably responsible for generation of a faceness, but most maybe it also is related to some kind of object perception as well. And mutual information or entropy using identical algorithm, identical dimension, they classify really poorly. And the last few seconds, this is the time course of the classification accuracy, and then across different paradigm, it's always the case that the phi-based classification is the best. So to summarize, I gave you an overview of IIT, and then gave you some 2 different interpretation of what the integrated information is. And then finally, I presented there is a possibility to empirically testing IIT with approximation, proper approximation. And then just a few words about BAT's experience. So if you follow my talk so far, then you can probably imagine that we can do this in the visual domain and auditory domain in animals and so on. And then also across individuals. And then if there is some kind of common topological properties of phi structure, phi patterns, like let's say this is my sort of imagination or hallucination, but if you record and then construct these 5 patterns from auditory cortex, then there's a lots of holes in it, for example. Whereas in the case of vision, it's always kind of clusters and tight and pyramid-like shape. Maybe the point is very different depending on the stimulus, but clearly it's different between vision and audition. And then if BAT's echolocation-based cortex, and we can compute this phi structure from BAT's cortex. By the time we, of course, have to make sure that IIT is reasonably correct, then we can make a prediction that okay, BAT's echolocation should be closer to audition or vision or nothing, which is the case where when BAT's phi patterns should collapse to 0 almost. And then this kind of approach, I would claim, dissolves or diminishes the difficulty of the hard problem. Thank you.
Thank you very much. I think maybe we can wait until the end and have a more robust panel discussion and leave time for that. And I will invite our next speaker up, Richard Brown. Richard, oh, wonderful. Richard is a philosopher at the City University of New York, where he also received his PhD. He is a member of the Space-Time and Consciousness Project at NYU, and his main interest is in the philosophy of consciousness with a particular emphasis on higher order theory, and that's what he's going to be talking about today. So thank you.
Thank you very much. All right, thank you very much for that introduction. It's really fantastic to be here. I actually first came to Tucson for the first time in 2002 as a graduate student, studying philosophy and psychology, working in a psychology lab, and we had heard about this mythical consciousness conference where everyone interested in consciousness came together, and I figured I had to be a part of that. So we came here as a group. I presented as a poster for my very first presentation, as a matter of fact, and the energy was dynamic, and not only that, but the culture of consciousness that these kind of gatherings bring about are really phenomenal. And it was there I realized that you could actually do this seriously and think about consciousness all the time. And so I want to thank the conference organizers for putting this together and for contributing to the culture of consciousness. Okay, so I'm here to talk about higher order theories of phenomenal consciousness. And so just a quick word about the word phenomenal consciousness here. Some people mistrust this word. Some people find it vacuous and meaningless, and other people don't. And I'm one of the ones that don't. So I think for better or worse, it's become part of our language. And the one thing I want to guard against is the idea that when you use a term like this, you are smuggling in something theoretical without having to argue for it. And so I do want to be very careful to point out that the way that I use the term is supposed to be theory neutral. And I'm citing a couple of people on the slide, David Chalmers notably, and also Josh Weisberg, two very different philosophers of consciousness, interested in different kinds of approaches to consciousness. But nonetheless, they endorse this kind of neutral idea that phenomenal consciousness just picks out conscious experience and its properties. And that leaves open the kinds of questions that I want to talk about, whether it belongs at the lower order level, at the higher level, whether cognition has it, whether it's only something that sensory states have or what. So I want to be completely as neutral as possible in that respect. So when we're trying to explain what phenomenal consciousness is, a theory is higher order in the way that I use those terms when it appeals to a kind of inner awareness. So we have awareness of things in the environment. We have also an awareness of things that are going on inside the mind. And a theory of consciousness is higher order when it claims that there's a special role for this kind of inner awareness. This is canonically summed up in what has been known as the transitivity principle, which goes back to the work of David Rosenthal, and it states that a mental state is conscious when the subject is appropriately conscious of that state. And we use the word conscious and aware here to be synonyms. Now, higher order theories then would be distinguished by how they try to explain what this notion of inner awareness is. And so the various kinds of theories that you find in the literature will try to give a differing account of what this inner awareness is. Traditionally, going back to maybe John Locke, and other people would argue maybe even Descartes and Kant and possibly Aristotle, so folk psychology seems to recognize that there are two basic ways that we become aware of things. On the one hand, we sense or perceive things in the environment, and on the other hand, we think about things. And so what you have found up till this point is theories sort of circling around these two areas. So we have higher order perception theories and we have higher order thought theories, and a large part of what's been going on currently is trying to figure out which of these two people think is more likely to be a good account of inner awareness. And these two kinds of things, perception and thinking, have generally thought to be being able to be grouped under one general category, namely the category of representation. And this can be canonically expressed, the reasons for this, can be canonically expressed by the argument that was given by Bill Lycan way back in 2001. So this is a quote from his analysis paper called A Simple Argument for Higher Order Representational Theories of Consciousness. It has three premises. The first premise is just a kind of way of phrasing the transitivity principle. It says that a conscious state is a state whose subject is aware of being in it. The second premise says that the of in aware of is that of intentionality. The third premise is that intentionality is representation, and from that we can derive that awareness of a mental state is a representation of that state, and also that a conscious state is therefore a state that is represented by one of the subject's mental states. So I think that this argument is in the background of a lot of theorizing about higher order theories. And what's interesting to me and what I want to focus on in my talk today is the way in which people who consider themselves in some sense to be a member of the higher order theory camp have tried to challenge each one of these premises. So I want to go through briefly and talk about how these kind of alternative theories have come about. And I want to start by what I think is kind of an interesting challenge because it originates from the author of the argument. So there's Bill Lycan and his student Wesley Surratt, and they recently have a paper, it's called Attention and Internal Monitoring, a Farewell to Higher Order Perception, which came out in Analysis in 2014. And there they think that there's something problematic going on in this argument that I just sketched, and they point to the second premise. So they say the problematic move occurs in the second premise. The of in the phrase aware of is not the of intentionality, intentionality. Instead, it is some other non-cognitive, non-representational relation. And you might think that's a bit surprising at first because we start off thinking, well, there are two basic ways that we recognize we become aware of things. On the one hand, perception, on the other hand, thought. And if we find some reason to doubt that there's any kind of room for higher order perception, then maybe we should be thinking about higher order thought theories a bit more. But instead, they deny that and are searching for some kind of non-cognitive, non-representational notion. And the reason for this is that in the empirical search for a kind of inner sense, they think that we've discovered that there is no good evidence for any kind of inner sense or higher order perception. And so they technically say that the higher order perception theory has been falsified. And instead, what we find is evidence that regular attention is the mechanism by which we become aware of our mental states. And furthermore, they think that the empirical literature has shown us that attention in this ordinary sense is not representational or not cognitive in that sense. And so they go on to say, this is from the same paper, that the tenability of this view, that ordinary attention is the mechanism that gives enable subjects to become aware of their mental states, is going to be dependent on us giving a theory or an account of what this awareness relation amounts to. So the mechanism is not enough. We need some kind of notion of what this awareness relation is, and they trot out two possible candidates. On the one hand, some kind of acquaintance, and on the other hand, they cite Bloch's 2007 paper suggesting some kind of awareness access relation. And so I want to look at both of these two proposals in turn. It may be somewhat surprising to see Ned Bloch's name there as a candidate for thinking about higher order theories because he's often associated with the first order theory. But what has become increasingly clear in the recent discussion about this is that Ned does endorse something like the transitivity principle, but what he wants to deny is that the way we explain that is by some kind of higher order cognitive state. So here's a quote from his exchange with Josh Weisberg and David Rosenthal, also on Analysis, which has been a really good place for debates about consciousness recently. So he says, Weisberg ascribes to me the view that pains matter, even if the subject is in no way aware of them. I, Bloch, strongly deny this view, noting that to say one is necessarily aware of one's phenomenally conscious state should not be taken to imply that every phenomenally conscious state is one the subject notices or attends to or perceives or thinks about. I deny the Rosenthal-Weisberg theory of awareness, not awareness itself. So it does seem to me as though there is a recognition in Ned's work that some kind of inner awareness is important, but we want an account of that. And so he has at various times proposed two kinds of notions of inner awareness that he would be happy with. The first is a kind of deflationary notion inspired by the work of Ernie Sosa. So Sosa famously remarked that, yes, it's true that we smile our own smiles, but the smiling of your own smile is not something extra in addition to you having a smile. It's just that you smile, and because of the way that we talk and the language that we use, we have to say, yes, it's also true that you're smiling your own smile. So that's a deflationary notion. And in a similar vein, Bloch has suggested, well, perhaps we can make sense of inner awareness along these lines. So when you have a phenomenally conscious experience of red, there's something that it's like for you. And yes, we also have to say that you're aware of that awareness, but maybe it's not anything extra in addition, over and above the first order state. I myself have always been very suspicious of this move. It doesn't seem to me to be able to do justice to the difference between conscious states and unconscious states, so that it seems that any kind of representation in the brain is going to be deflationarily self-aware in this kind of way, and it doesn't really seem to me to be an alternative. And even if you do like this kind of view, it certainly is not going to be the kind of thing I think that those who were attracted to the higher order perception view, like Lycan was, are going to account for. Now, to endorse, I'm sorry. Now, the self-reflexive view has been something that Bloch has also suggested. So he says, look, if you can force me out of my deflationary standpoint, then what I will do is fall back on some kind of self-representational view so that the inner awareness that's important here will be somehow a part of the state itself. But it's important to note that the kind of inner awareness, which if it is a part of the state itself, would have to be something that's not intentional, something that's not representational, something that doesn't involve intention or noticing or any of those kinds of things that were on the list. And it doesn't really seem clear to me that we have a viable alternative here. Rather, what it looks to me is that we have the promissory notes or request for someone to develop an alternative account. And so really what I think is going on here is that the list of alternatives boil down to just one, and that's acquaintance. this. And in fact, we have seen several kinds of theorists come out and say, yes, we want a higher order acquaintance type of theory. And so here's David Chalmers in his recent exchange, which also came out in Analysis, a symposium on his book, The Contents of Consciousness. And so he says, in response to Ben Hiley, which this particular quote came from, he says, I think the most plausible line here is that phenomenal awareness is an acquaintance involving relation by its very nature. In nature of awareness, to be aware of X entails being acquainted with one's awareness of X. So this seems to me to be something like the notion that Ned Block was looking for. You have an awareness of red and also an acquaintance with that awareness. And this is the footnote to that passage, quite kind of a long footnote. But here Dave is saying, yes, he recognizes that this is a relative of higher order representational theories, but specifically the kind of self-representational views that we find inspired by Brentano and have been explored by Kriegel and Willeford recently. And of course, the big difference here is that this is a non-standard kind of representation. So I think that what these views have in common is that they're trying to challenge the second premise of the simple argument. Yes, we think that there's kind of an awareness here, but no, we don't think that this awareness involves intentionality. It's also important to note, I think, that Dave's view is non-physical, which is well known, and people have tried to develop acquaintance theories from a physicalistic perspective. I think that's going to be rather difficult. So I want to come back and say something about this, but before I do, I want to sort of look at the third premise. So the third premise of that argument was the claim that intentionality is representation. And many people have sort of started to think, well, possibly we might challenge that premise. And most notably, I think recently, Sam Coleman has developed a kind of quotational higher order view. So his view is that you have a higher order state. It tells you roughly that the following state is present, it has a mechanism for quotation. And then the actual state that's present gets somehow embedded in that very higher order state. And this is explicitly endorsed as a way of generating intentionality that is not representational. So here's a quote from his paper. He says, quotational higher order thoughts make one aware of sensory states, and the of is indeed the of intentionality, but it is false that this of demands to be understood representationally. Something can be an intentional content by being contained, literally a content. The content of a completed quotational hot includes its embedded sensory state. So there are other versions of quotational higher order theory out there. There's a recent one that's defended by Vincent Picciuto, and I don't think that, I'm aware that he would not endorse the view that this is a non-conceptual type of representation, but all of these views, whether the details here in the terminology are a bit tricky, but the thing that they all have in common is that they want to deny that it's standard kind of intentional conceptual representation that's involved, and they're looking for another notion of what this kind of inner awareness could be. Now, I think that these views all kind of share a similar kind of worry here. So I think that worry can be brought out by asking this kind of question here. And the question is, yes, when we have a phenomenally conscious experience of red, there's something that it's like for me. There's a reddish wave towards me. I'm aware of a mental quality and thereby by hypothesis also aware of my awareness of that mental quality. But the question really for me is what happens when that mental quality is not in your consciousness, when it's out there unattended, unaware in any sense. And the question I want to ask is, what is that property like? So is the blueness of the blue still the way that it is when you're phenomenally conscious of it, or is it some other way? So on the left here, I think this is the view that some people have, that these properties just are the way that they are, and then the only thing that happens is that you become aware of them. Whereas on the right-hand side over here, we have the view that unconscious qualities, the blueness of the blue is not there until the appropriate inner awareness is directed in that way. So I think these are roughly the only two options that you can take, and either way, I think that the ultimate problem here is that you've ended up giving up on an important explanatory goal of a theory of consciousness. So if you say yes, that the unconscious qualities, the redness of red is exactly there as it was in my consciousness when I'm not aware of it in any way, then I think that you're going to end up having to say something like pan-qualityism is true, that these things are a fundamental part of the nature of the universe, and that it by itself isn't so bad. But the bad part to me comes by admitting that we cannot give an explanation for that part of how consciousness arises. So yes, on this view, we can explain the difference between a conscious mental quality and an unconscious mental quality, and that difference would amount to an awareness of the one, but we can't explain why the mental quality is the way that it is, or how that quality shows up in our conscious experience, so to speak. So I think we've given up on half of the explanatory project. Now, on the other hand, if you say, well, no, these mental qualities aren't that way when you aren't aware of them, and then you add the awareness and suddenly there's the blueness of blue and the redness of red. I think that you've also similarly given up on the explanatory project because you're going to end up postulating that there's some kind of brute causal mechanism in the universe that just so happens to magically make it the case that when these two things get together, then there's phenomenal consciousness. So I think that there you've also given up on trying to explain how it is that these mental qualities we're aware of get to be the red that we're familiar with from our conscious experience. Now, I do want to add very quickly that I don't find these knockdown arguments. In fact, I'm very firmly convinced that there's no such thing as a knockdown argument in philosophy. And in fact, I do find plausibility in these views. So sometimes in my more optimistic moods, I think to myself, what are the problems here? I don't know. So the redness of red is there. I'm just not looking at it. What's the big deal? On the other hand, I say, hey, brute causal forces in nature. Explanation's got to stop somewhere. Maybe it stops here. So it's not as though I think that these are reasons to abandon that view, but I do think that these are costs, and that it would be at least worth getting clear on what the other side can do. And then in my darker moments, in my more pessimistic moods, when I'm suffering from a bout of depression, I think, well, wait a minute, why are we giving up on concepts so quickly here? Why are we looking for a non-cognitive, non-representational notion of inner awareness when we already have higher order thoughts available and we shouldn't abandon them too quickly? They have the advantage insofar as at least they start with something recognizably psychological. And there are those of us who think that that's an important starting place for a theory of consciousness. Consciousness seems to me to be something which lives at the psychological level, and it would be nice to be able to explain it in terms of other things which are fairly well understood in terms of psychology. Now, I don't think that that's, again, much of a good reason to reject a view, but I do think it's at least a good reason for exploring the alternatives. And that leads me to the first premise. So the first premise is that of the simple argument from Lycan. The first premise was that a conscious state is a state whose subject is aware of being in it, and many people have thought that this is sort of definitive of higher order theories, and that a theory that denies this, at least in the way that it's expressed there, is going to be something that's not a higher order theory. But even this first premise has been challenged by higher order theorists, so there's one there challenging, in the middle of challenging it, and you may recognize that person as me in my non-bearded form. So you may wonder, how can something as basic to the higher order theory as what is the transitivity principle be challenged? And I want to explain that, but by doing that, I want to back up first and give an analogy. So I think that if you think about perception and theories of perception in the philosophical literature, what we find there are basically two competing views. On the one hand, there are those people who think that the world has the properties that it has independently of our perception. The sounds and so forth are out there. And then what happens when we perceive them is we simply enter into an awareness relation with those things. This view is sometimes called direct realism, although if you don't like it, you could call it naive realism. On the other hand, there are the representationalists, and here representation is supposed to be explicitly contrasted with relational. So a representational theory of perception says you don't need to have the tree with the property of green out there. All you need to do is have the right kind of representation representing that there is a tree out there. And so these kinds of views, I think, are well known from the philosophy of perception. But what's interesting is that within the higher order theories landscape itself, we have seen a similar kind of debate being developed. So on the one hand, we have what I will be calling the traditional higher order thought theories. And the traditional higher order thought theories all have a kind of explanatory project in mind. What they note is that on the one hand, these states occur consciously, and sometimes they also occur unconsciously. So they take the explanatory project of higher order theories to be starting with a state which is unconscious, say a representation of something green in the environment, and then the question is, how does that very state turn into a conscious state? And then we postulate a mechanism that's supposed to help us understand that, and in this case, the mechanism would be some kind of higher order thought. And so the higher order thought is supposed to somehow take that state that is there and turn it into a conscious state. And then the question that has been debated extensively, and which you may have heard some of the debates going on recently, is, well, do we have to add anything else? Do we have to strengthen the relationship? Do we have to say more than that the two states are logically independent and add maybe that they're built into a complex, or that there's some kind of global state that they're integrated into? Maybe we have to include the wide intentionality of the first order states. So a lot of the debate has been trying to understand what the correct relation between higher order states and first order states has to be in order to generate a conscious experience. On the other hand, I think that there are some well-known problems for this kind of view, and I'm not really going to talk too much about these problems, but I will just sort of mention them. So on the one hand, there's the problem of the rock, which goes all the way back to Alvin Goldman, and this is the problem of understanding how it is that having a thought can turn something into a conscious state. So it's a claim that it does it for first order states, but it's not to do it for rocks when I think about rocks. And of course, there's been a lot of discussion about this problem, but in my opinion, no good answer from the traditional theorists has ever been given. So I'm sure we can discuss that. On the other hand, though, there's the problem of misrepresentation. And this is the problem of what happens when the two levels of content mismatch. So what happens when you have a first order representation of red, you have a higher order representation of yourself as seeing blue. The question is, well, what's going on there? And the traditional higher order theorists have said, well, nothing is going on there. You don't have a conscious experience because you have to have a match between the contents, the first order state, the higher order state, they have to match somehow. And that just seems to me to be totally ad hoc and not supported by anything within the theory, which isn't question begging. So I know that those are very quick, but even if you don't really believe that these objections are fatal, they still give us some reason to search around for another kind of view. And so partially because of this, people have turned to exploring explicitly non-relational higher order thought theories. In my own view, my reading of David Rosenthal has him as a non-relational higher order thought theorist, but that's neither here nor there. Now, of course, you could say, did he change his mind at some point? I don't think that's a very interesting question, but maybe yes, maybe no. The big point that I want to make is that there are two different kinds of theories here. So on the one hand, the kind I was previously discussing, and on the other hand, a different kind of theory which doesn't ask the same kind of question. It doesn't give the same kind of answer. So from a non-relational point of view, the goal of the theory of consciousness is not to tell me how a first order state turns into a conscious state, but it's rather to account for the mental appearances of the subject. So we start with this idea that a consciousness involves the mental appearances, something I think that is widely accepted by many different people. And then we note an important datum, which is that sometimes it appears as though there's a first order state there, even though when we have good reason to believe that there are no first order states there, but the subject doesn't seem to notice, and from their point of view, everything seems to be the same. So this is the starting point for the non-relational version of the theory. We note, well, gee, if you can have the higher order state and the subject's appearances are the same, the first order state doesn't seem to be really contributing to the phenomenology or to the conscious experience of the person, and so why not just say that the higher order state is responsible for the phenomenology. I think that this has all automatic advantages. There's no problem about rocks because we're not thinking about something and turning it into a conscious state, and there's no problem about dividing the labor here because there's no question that on this view it's explicitly the higher order state which is doing all the work. Now, there are many different versions of this kind of non-relational theory, and there are, the differences between these theories can be brought out by asking the following question, and the question is, well, which state is it which is phenomenally conscious? And I understand that question to be asking, well, which state is it that there is something that it is like for the subject to be in? So the traditional theorists have said, well, it's the first order state. It's the state that you become aware of and somehow gets enveloped or globally integrated or something like that, but it's the first order state which is sort of determining what the phenomenal character of the experience is like. And then you can ask, well, what happens in mixed mass cases, or in the worst possible case, what happens when the first order state is not present at all? And so in response, Rosenthal and Weisberg has suggested, well, maybe it's the non-existent intentional object of the higher order thought which becomes phenomenally conscious. And some people have found that to be very puzzling, that a phenomenally conscious state turns out to be a non-existent state. And I think that there is a way to make sense of that. I don't think it's the most puzzling thing that I've heard at this conference so far, but it is definitely, I think, something that you want to avoid having to say. And so partially because of that, I've suggested that we should think that it's the higher order state itself which is phenomenally conscious. And so I've coined the term the horror theory of phenomenal consciousness, the higher order representation of a representation, as a way to distinguish this kind of distinctive approach to the higher order theory. So this has all been kind of abstract, and I want to just try to picture it a little bit. So according to the horror theory, we start with the physical objects out there. They will have various properties. We could call that object blue, but there will be no blueness as is experienced in consciousness. Rather, instead, there will be just some physical property which will cause in the appropriate perceiver a representation of that kind of object. And you can call that a qualitative character if you want. Some people don't really like calling it that because at this point, according to the theory, there is no phenomenally conscious experience going on. But nonetheless, There are some reasons to think that you should call it that. Either way that you go, though, there is no phenomenal consciousness until you have the appropriate higher order state representing that you are in fact seeing blue, and then at that point it becomes like seeing blue from you. And importantly, the way you experience it is as described by the higher order state. So in this case, it would be like seeing something in the external environment, and that thing would be blue. The first order state, the state which is described by the higher order state, is the target of the higher order representation. And we can say that there's a sense of consciousness in which that state is conscious. We could call it state consciousness, but it's not phenomenal consciousness. Phenomenal consciousness on this view is a matter of what the higher order state is doing. So if we adopt the kind of language that was introduced by Uriah Kriegel, we could distinguish the subjective character of the experience, which is that which all phenomenally conscious experiences have in common. And on this view, what they all have in common is that you are representing that you are yourself in some various state, and we would distinguish that from the phenomenal character of the experience, which is the way in which all these phenomenally conscious experiences would differ. So on the horror theory of phenomenal consciousness, that would be the specific way you represent yourself as either seeing blue, hearing a sound, feeling pain, or whatever. So the difference between the conscious experiences is given by the content of the higher order thought. And the crucial claim here is that even if the first order state were missing, subjectively, there would be no difference. It would still be like seeing blue from you. You would not be able to tell the difference. Now, of course, there would be some difference in your psychological functioning. So if someone asked you to press a button or do some other kind of task, then you would fail at it because the first order state, which is usually driving the behavior, would be missing. So that's roughly the view of consciousness that I think that is an alternative to the kind of acquaintance views that we were speaking about earlier. And I do want to kind of try to head off a couple of common objections that I hear when I talk about this. So on the one hand, this is not a version of self-representational theory. Many people have suggested that it sounds like a self-representational theory, but it isn't. And the key difference, of course, is that the higher order state doesn't represent the higher order state, which is the basic tenet of self-representational theories. The higher order state represents one's self, so your very self in some way, but it doesn't represent the very higher order state itself. And so yes, if you wanted to use the language developed by Miguel Sebastian, you could say it's a self-involving theory or something like that, but it's not as though the higher order state is self-representational. In response to that, some people have said, well, gee, it sounds like you're denying the transitivity principle, because here's some conscious experience, it's phenomenal consciousness. You've already said that phenomenal consciousness is the kind of neutral term that everyone uses, and now you're telling us that it's just this higher order state. So where's the transitivity principle? It seems like you've given up on the traditional view of transitivity. And to that I say, yes, we have given up on the traditional view of transitivity, and the traditional view posits a relation between the first order state and the higher order state is somehow explanatory important. And on the current view, there's no relation that's important between the two states. But that doesn't mean that we've given up on the transitivity principle in general. This is a higher order state, higher order theory of consciousness, and so we would interpret the transitivity principle as saying that a phenomenally conscious state consists in my being aware of myself as having first order states, and that's a very strong endorsement of the transitivity principle, but understood in a non-relational way. At the same time, I think that one of the benefits of this kind of view is that it preserves many of the things that first-order representationalist theories try to communicate. So here we have some consciousness, you're not aware of it, you're not noticing it, you're not perceiving it, you're not attending to it, and so that's a key element of first-order views that's preserved by this kind of higher-order theory. And so we could even say, along with many first-order theories, that conscious state is one you're conscious with, not one that you're conscious of, and even that turns out to be true on this view because the phenomenal consciousness is one you're conscious with, but what you're conscious with it is of yourself as having a mental life. So there are key differences between first order theories. Okay, so now we've arrived at a place where I think that we have kind of a fork in the road. On the one hand, we have those who want to say, look, it's got to be some kind of non-intentional, non-cognitive, non-representational theory of inner awareness. And on the other hand, the most plausible view of the higher order thought theory, I think, is one that involves just intentional representations and nothing else. So you might wonder, is there any middle ground here where we can try to have the best of both worlds? And so I think that maybe there is, and in some work that I've done with Ha-Kwan Lau, we've explored what we call joint determination views. And joint determination views really try to understand a way of combining the things that we were talking about with respect to acquaintance and the things that we're talking about with respect to intentional representation into a way that combines them. So just as a way of trying to illustrate what the differences are here, this is a joint determination view would start off in the same way. You have some physical properties out there, but nothing like the colors that we experience in consciousness. That will cause in a perceiver the appropriate first order state, still no consciousness until there is the appropriate higher order state, at which point you become aware of the first order state, and then there's phenomenal consciousness. So on this view, the big difference is in the content of the higher order state. On the one hand, the higher order acquaintance views try to find a role for the first order state that's more intimate, that's not distanced by a layer of representation. On the other hand, the horror theory tries to say, well, it's all just a kind of intentional representation. So we posit that there's some kind of mix in between. There's a part of the higher order representation which is estimating the reliability of the signal at the first order level. In this case, it would be something like I am vividly perceiving, or I am mildly perceiving, or the thing is just noise, I'm not perceiving at all. And then on the other hand, there's a pointer to where the first order state can be found. Now, I understand mental pointing in kind of analogous terms to hyperlinks in HTML. So I have this here, I'm vividly perceiving the content of representation F. Representation F is not supposed to be thought of as a description in conceptual terms of the first order state, but it's rather just giving you the address of where the first order state lives, maybe somewhere in V4 or something like that. And if you were to sort of click through, you could call up the first order state and sort of introspect it, but at this point there would just be a kind of, this is vivid, in a pointer to a certain location. And so the way in which this is similar to the traditional views is that we have separated the subjective character from the phenomenal character. And if it had been the case that the object had caused the first order representation of red, so if representation F were not a first order representation of green, but instead a representation of red, then the theory postulates that what it would be like for you would be like consciously experiencing red. So the first order state directly matters in a way that it doesn't on the horror theory. Now, of course, the big difference is that on the traditional view, if you were missing the first order state, they posit that there's no phenomenal consciousness at all, whereas on the joint determination views, we postulate that there is nonetheless some kind of conscious experience. So if the higher order states represents that you are vividly experiencing the content of representation F, and if there is no representation F at the first order level, nonetheless, the theory says you're gonna report that you're vividly experiencing something, because that's what the higher order state says, and that's what determines what it's like for you. So you would have the experience as of vividly perceiving something, but then if someone asked you what it was that you were perceiving, you would be at chance with respect to giving the correct answer. So that's a very different kind of view than the traditional views, which postulate that in such a case there is no conscious experience. And we think that actually this kind of view does a very good job of handling all the puzzling empirical cases having to do with the Sperling partial report paradigms and the work that's been done on that in the current times. Okay, so as a way of concluding then, I do want to point out that I think that the joint determination view suffers from the same problems as the higher order acquaintance views, because it just becomes extremely mysterious to me how it is that referring or pointing or somehow indexing or something like that to a first order state lets the content of that state into the phenomenology of the subject. So it just doesn't seem to me to be any good account of how it is that these mental qualities come about. So it seems to me that if you wanted to be a higher order theorist, the horror theory is your best bet. It's the best bet at giving an explanation of how consciousness arises. And so in other work, I've tried to extend this. So in work with Pete Mandic, we've looked at how this applies to cognitive phenomenology, and we think it straightforwardly does. And then a current work I'm doing with Joseph Ledoux, we're trying to expand this to emotional consciousness, and we think that really the horror theory is our best chance to make sense of the phenomenology of emotions, which we find to be very complex. So I think it's very exciting time to be working on higher order theories here. Now, of course, you might wonder whether or not there are any good reasons to accept something like the horror theory, as opposed to it being the only good option in town. And I think that there are. I think that there are good arguments that we can give here, but since I'm running out of time, maybe we'll save those for discussion. So thank you very much.
Thank you very much, Richard. And now we're going to move to our last speaker, Jakob Hohwy, who is a professor of philosophy at Monash University in Melbourne, Australia. He's also the director of the Cognition and Philosophy Laboratory, which is a highly interdisciplinary research unit. He's the deputy editor of the Neuroscience of Consciousness, which is the official journal of the ASSC. And he's going to help give a consideration of these multiple pathways. Now, I have to confess, he might not be exactly impartial, because in 2013, he published a book from Oxford University Press entitled The Predictive Brain. So he might have some biases. But we look forward to his talk. Jakob.
Thanks, George. You're right, the game is rigged. But we'll see how we go. So the brief was to talk to these 5 roads to consciousness and provide some kind of synthesis, or step back a bit and consider from the perspective of philosophy of science, philosophy of consciousness, philosophy of mind, what we should say about them. The first thing to notice is that there are many more than 5 roads, as you all know, and we can mention quite a few of these. So in addition to our 5 roads that we've seen so far, we've got metacognitive theories, we've got high-order certainty index theory, which might be a type of high-order thought theory. We've got Clearman's radical plasticity thesis. We've got Lame's recurrent processing. We've got attended intermediate level theory, just Prince's stuff. We've got first-order theories. George might be one of these guys, maybe Kylo Ren, I don't know. We've got virtual reality theory, Metzinger, Ravensur style theories, and social theories like Chris Frith's consciousness is for the people theory. And we've got many more, that's why we're here. I'm sure you can all think of at least 13 other theories that I haven't mentioned so far. So we need to put that on the table. But what I'll do, I'll just focus on these 5 theories. The notion of a road to somewhere, it's a metaphor that's too good not to use. So here's a map of Europe showing that all roads do indeed lead to Rome. We might ask whether all roads lead to consciousness, or where they lead. There are lots of different metaphors we could invoke: a tangle of roads, gridlock, dead ends, and being totally lost out in the forest. I think that all of these metaphors apply to at least 1 or 2 theories of consciousness out there. What I like is this one: when you come to a fork in the road, take it. It's a beautiful, every talk should have something by Yogi Berra, I think. And it's true, of course, this is what we should do, because no matter how you think about consciousness, and I hope to make this a little bit plausible in this talk, you should end up with the prediction and minimization theory. So here are our 5 roads, and we're setting aside all these other fine roads to consciousness. One thing you might worry about, given the kind of number of different theories and how different they look, and how differently, as you can see in these great plenaries we've had so far, how differently they're presented, is that there's too much divergence to really hope for any progress for the science of consciousness. I think there is quite a lot of convergence, and I'll try to split that up in this talk in 2 different themes. So one is convergence in the explanatory targets. There is a way in which they're all aimed at consciousness after all, and then some themes that converge as well in the mechanisms that are proposed to underlie consciousness. So I'll do these themes in turn. So here's one way of expressing the explanatory target for the workspace theory. I'm just cherry-picking expressions here, but you'll get the drift. The target here is current conscious content, which is reportable verbally or by an intended gesture. Supervision, limited capacity, and re-entry properties are then seen as especially important for consciousness, and that's what characterizes the global workspace. Here's the OR theory that you heard about yesterday from Stuart. It's a broad target to begin with. Moments of conscious awareness and or choice, subjective phenomenal experience of internal and external worlds, a sense of self, feelings and choice, control of voluntary behavior, memory, thought and language, internally generated images, and consciousness is said to consist of discrete events of varying frequencies. And then there's this notion of proto-consciousness down at the bottom of it all somewhere. IIT is this very strict and stern view that you saw. It begins with some axioms. translated into postulates, real kind of scholastic style. We've got existence, composition, information, integration, and exclusion. And it's also aimed at, as they say, the classic distinction between level and content of consciousness. Hot theory, it's aimed at explaining content consciousness. It's conscious awareness. This is from Lau and Rosenthal. Conscious awareness, perceptual processes that occur with subjective experience of which we are aware and about which we can report under normal circumstances. The prediction error minimization theory is a little bit the odd one out of the bunch here. It just says, well, I can explain what the brain is doing, and given that consciousness sits in the brain, I must be able to explain consciousness as well, however we want to define it to begin with. So I'll play more with that as we go forward. Notice that there's quite a bit of overlap here. All of the different theories seem to be interested in conscious content. And of course, there's some spread as well in terms of how that is conceived. Some seem to be more focused on what we might call phenomenal consciousness with NetBlog. Others seem to be focused on access consciousness. A few of them take the notion of levels very seriously. IoT, this is an important aspect, as we'll come to as well. Others broaden it out even more, like Orgor, with a focus on choice and self and so on. But there's quite a bit of overlap. So I want to say that, and there's openness as well with PIMP. I want to say that no matter what the convergence is, the degree of convergence or the degree of divergence between these theories, they should all answer somehow to what Nao mentioned before that we haven't talked about so much, namely the neural correlates of consciousness. It would be bad for a theory if it comes apart from the findings of the neural correlates of consciousness given their own explanatory target. And this is interesting because there's been some debate recently since David Chalmers started to write about the neural correlates of consciousness in particular, about how we can find that. There's some challenges, methodological challenges that we should talk about. And this will lead us down the garden path to the predictive coding kind of view. So the first challenge has to do with what it takes for something to be experienced consciously. And there's a focus on contents, but we should never forget that contents always occur in a kind of global conscious state. This is best explained with an example that goes back to John Searle in 2000. So a typical paradigm in the search for the neural correlates of consciousness is binocular rivalry. You present one grading to one eye, the other grading to the other eye, and conscious experience shifts between them. You take a participant, whack them in the scanner, give them binocular rivalry, and see what changes in the brain as this happens. And John Searle just points out, and this is a really strong intuition, that there's something that we'll never learn by doing it this way, because that participant was already conscious when we put them in the scanner. So it might tell us something about selection of a content into consciousness, but it doesn't tell us about what consciousness is, because the creature was already conscious. And Searle has this idea, we don't have to buy into that, but it's intuitively quite appealing, this idea that there's already a kind of unified conscious field that was in existence before that happened. So what this tells us is that we should always conceive of contents as being injected into or inserted into global states. And that immediately opens up some methodological issues about how can you study this, and also in terms of the data we can get out in terms of and the experimental designs in terms of, and that's what the cross means, the interactions between the two. It might be that certain kinds of contents changes your overall state, or it might be that your overall state changes some of your contents. We have to take that into account, and that's the first challenge, which is not very well recognized, I think. The second one has come up in a series of papers recently, began with Steve Miller, and then there's a bunch of other people writing about this as well. So the idea here is that as you do your experiment on the neural correlates of consciousness, you might find a nice tight correlation between the conscious experience that people are reporting and then some causal series of neural events. And then you might ask a further question: which one of these that correlate really closely with the conscious state, which one of them is the true constituent? So you might have a conscious content and it's correlating nicely with some neural state described at the systems level, but you can go deeper. You can go down to maybe a cell level or molecular state level or down to a quantum level as well. And you have to ask yourself, which one of these levels is the most informative with respect to the fact that we now have a conscious state? And here you also have to do, this is something in particular IIT, or and maybe also the predictive framework have to deal with. And here again, we have to figure out a way of doing interventions, a way of screening off some levels. And that's, of course, much harder now. We don't have cause and effect structure, but we have instead something that is constituted or has a mereological structure or something like that. But it has to be done, and maybe we can do it by holding the systems level constant and see whether we can change down to the quantum level and see whether there's any change in conscious content. So those are the two challenges. First challenge has to do with the fact that contents always occur in a global conscious state. It would be nice if we had some kind of whole of brain or overall systems approach in order to deal with this, so we can have an idea of what the global state might be and then look at what contents within that global state look like. And that will enable us to look at interactions between those two levels. And then there's the screening off problem. What would be nice here is that when we perform our interventions in order to really identify the neural correlates of consciousness, is that we try to carve the brain at its joints. If we have some kind of theory that allows us to say, this is the right place to do the intervention. If we can do those two things, then we might be on the right track. And here I want to just step back a little bit and take you back to a distinction that Dave Chalmers introduced back in 2000 in his discussion of the neural correlates of consciousness, having to do with arbitrary versus systematic neural correlates of consciousness. So here's what he says. He says, find a neural system whose states do not just arbitrarily correlate with the phenomenal contents and states in question, but which vary along a corresponding systematic dimension or a representational system. If you can do that, then the NCC in question will have much greater potential explanatory and predictive potential or powers. So I want to use that and say, well, we should have a joint satisfaction of this systematicity requirement that allows us to address these two challenges. And how we might do that is to ask two questions. What is the brain's overall job? That's the whole of brain approach, the overall systems approach. And then we have to say, what's the basic mechanism in the brain that allows it to do that job? And lo and behold, it turns out that the prediction and minimization scheme that Anil set out so nicely yesterday is a good candidate for delivering just this very comprehensive representational system. The idea here is that the brain's overall job is to minimize the long-term errors prediction error, and that it does this, in our brains at least, in a hierarchical Bayesian inference system, which has the right kind of prediction and minimization mechanism repeated throughout, so we know where we should do the cut, at least in theory. So the first part of the talk is an invitation to put the prediction and minimization scheme at the bottom of our attempt to identify the neural correlates of consciousness. So it's not just that we should find the minimally sufficient neural process for content in a global state, it is that we should find the minimally sufficient neural prediction and minimization process for content in a global state. And this then constrains all the other roads to consciousness that we're talking about, because they should be interested in finding the neural correlates of consciousness themselves. So that's the first point that I want to make, and that reveals my biases in favor of the prediction and minimization scheme. So the second half of the talk will be about the proposed mechanisms of these different roads to consciousness. What kinds of processes do they say are actually important for generating consciousness in the brain? The workspace theory looks at a mechanism for integrating the supervision, limited capacity, and re-entry properties. There's an important notion here of finding a mechanism for ignition, a kind of crossing of an evidence accumulation threshold for entering the global neuronal workspace. Or looks at neuronal microtubule quantum computations that accompany consciousness or proto-consciousness. IIT, as we saw, looks at some kind of mechanism for building up phi complexes for levels and qualia at the same time. Higher thought theory, as we have seen in Richard's talk, there's lots of different versions here, but the basic idea of the original higher thought theory is to have some kind of mechanism in the brain that allows you to have higher thought that results in you being aware of a first-order representation. The prediction error minimization scheme just says it's prediction error minimization. We know that there are some issues for each of these. What does it mean for something to be a threshold? In this sense, what's different in the processing before and after crossing this threshold? How do you scale up from proto-consciousness to full consciousness? Is phi too promiscuous? Does a sheet of paper have phi and is therefore conscious? What happens with empty high-order thoughts? And for the prediction and minimization scheme, you might ask what the evidence is for it. In spite of all these issues and the apparent differences, I want to say that there are some common themes here. There's convergence in how these theories, and also quite a few of the other theories that we're not talking about, what they present. So on the one hand, there's an element of uncertainty reduction, I think. So for the workspace theory, this element is about evidence accumulation. So you have to ignite into the global workspace, you have to accumulate enough evidence to be worthy of being in the workspace. Accumulating evidence is getting more certain about your situation. I don't know about or maybe objective reduction is a kind of uncertainty reduction, not so sure. IIT is all about excluding possibilities, as we saw. It's about saying, I'm in this one state, not in that state. Higher order certainty index theories, which is the version of the higher order thought theory that I like the best, proposed by Hakwon Lau, says that consciousness is all about setting a criterion to optimize the variable signal to noise ratio, which is also about minimizing uncertainty. So this it's there in different ways in a lot of these theories and also in some of the other theories that we're not talking about. The other element that's there is some kind of top-down or feedback element, kind of thing that Anil talked about yesterday. So in the workspace theory, this is revealed in the neural correlates of consciousness, that once you enter the workspace, then you have feedback in the brain. For or I don't know. Maybe where the microtubule action really is where feedback hits. I'm not so sure. IIT, well, there it turns out that if you have a pure feed-forward scheme, then there's no phi, so no consciousness. You require backwards connections in order to get that. For higher-order certainty theory and higher-order thought theories, there's also an element of looking back down at representations lower down in some kind of hierarchy. And I want to add to this George's observation in a recent paper that top-down connectivity seems to be central for the global state of consciousness as well, coming out of anesthesia-type studies. So top-down and feedback elements seem to be there as a common theme in a lot of these theories. So you'll notice that I've left out the prediction and minimization scheme here from that, and that's because uncertainty reduction and top-down is the bread and butter of the way we talk about it, and you would have seen that quite clearly in Anil's talk yesterday. So this immediately kind of supports what I said in the first half of the talk, namely that it seems like the prediction and minimization scheme would be a good conceptual framework for all these different theories to treat as the neuronal system that lies at the bottom of attempts to reveal the neural correlates of consciousness. But it also begs the question whether maybe the prediction and minimization scheme could be its own theory of consciousness. And the problem there is, as Anil also said yesterday, it is not a theory of consciousness. It's a theory of how the brain works, how perception works, how action works, and so on, but it doesn't really say anything specifically yet about consciousness. So can we somehow build on the notion of prediction and minimization to get to consciousness, or do we need prediction and minimization plus something else? So how might we go about thinking of this? I won't go into the details of what the prediction and minimization scheme is. Anil gave a brilliant exposition of that yesterday. The core idea is that creatures like us, we maintain ourselves in our expected states by minimizing our long-term average prediction error, what's sometimes called the free energy, and thereby we approximate Bayesian inference, so we get to represent the world by minimizing our prediction error. The thing is, there are many ways of minimizing your prediction error. The world is a noisy, uncertain, and changing place. Different creatures occupy different niches with different kinds of challenges, and there are many trade-offs and balances that you have to take into consideration. So your internal model might be very precise, or it might be very simple. There are costs associated with both. You have to find some method of finding a balance between those things. You might be having a very deep cortical hierarchy, so able to represent a deep causal structure of the world, or it might be very shallow. You might be prepared to revise your models before you act on the basis of those models. before you enter what's called active inference. Or you might be totally biased towards active inference and have very little desire to update your model. And there are all these sorts of trade-offs and balances that you'll be able to see played out in different creatures. So the picture is a bit like this. You have various creatures. They each do prediction and minimization. And we might be able to single out some types of creatures, primates, for instance, that we all would agree are conscious. And then we might be able to single out some other creatures, or things, organisms, maybe E. coli, that we would say is not. They're not conscious. We might disagree about that, but let's say for the sake of argument that that's the kind of distinction we make. Then you let the way that prediction and minimization is done in the conscious creatures feed into your theory of consciousness. And that might tell you something interesting about consciousness. So how would this go? You would ask first a question about how these conscious creatures process or engage in prediction and minimization at a systems level to get the kind of overall whole of brain, whole of system approach. And here I'll just put some questions out there that might shape our prediction and minimization theory of consciousness. It might be that in conscious creatures, prediction and minimization is implemented with predictive coding specifically. It might be that in conscious creatures we have a very deep hierarchy where we have evolved an extra capacity for taking it offline and engaging in counterfactual prediction and minimization that creates a kind of virtual reality that we can enter. Some people might like that idea. It might be that in conscious creatures that there's an explicit rather than implicit context-dependent expectation for the overall prediction error rate, which might relate to confidence. So there might be things we can say at a whole of system kind of level. And then the next step is to go down to the content level. Well, how might this work at the level of individual conscious contents? What is the distinction, for instance, between unconscious and conscious contents? And it might be that we can find a distinction here between, on the one hand, detection of things in the environment, and this might speak to just a simple notion of gathering information or accumulating evidence. And then there might be a different thing that happens, namely when you invert the generative model, you select a particular hypothesis about what it is that you're looking at and how these things are interacting with each other out in the environment. That might give you recognition. And that flip might be what's associated with consciousness. Two different types of processing. It might be that you can define something that looks like an ignition threshold as well within a system that is geared for prediction and minimization through both perceptual inference and active inference. It might be that the threshold is something you've learned. You've learned something about when precision of the evidence accumulated reaches a level that you have learned in the past is conducive to efficient prediction and minimization. I'm not saying this is the theory, but these are the kinds of things that we can get by looking at some of the ideas from the other roads towards consciousness through the lens of prediction and minimization. There's a kind of value added from doing that. And then, of course, you want to look at the interactions between these two. The overall confidence that you are now minimizing prediction error at the expected rate, and then different types of contents and how they interact with each other. So what I'm doing here is I'm stealing and grabbing from the other roads to consciousness and from other roads apart from the four that we're discussing here. And then I play back some of these ideas within a unified prediction and minimization framework. So I think this is already quite interesting because you might learn something new about the proposed mechanisms. You might also get, by playing with the prediction and minimization scheme, you might get a kind of overall conception of what consciousness is, and you might add some new empirical and philosophical perspectives. So the overall conception might look something like this. I'm not saying this is a theory, but it might look something like this. Consciousness happens when prediction error is being minimized. So you're actually suppressing prediction error. It's not that you've already done it. You're in the process of minimizing prediction error in one top-down predictive model at the expected overall rate. You want something deeper? That's fine. We can do that as well. We can repeat what Anil had yesterday. It's the inversion of Descartes under the free entity principle. It's not that you think, therefore you exist. It's that you exist, therefore you think. I'll leave it as an exercise to figure out what that means. It does make sense. So the third thing here is that you can add new empirical and philosophical perspectives as well. And I think Anil's talk yesterday was a beautiful example of doing both of these, and all the nice work that's done in the Sackler Center. So interesting ways in which expectations shape your perception, explaining deep and subtle aspects of experience in terms of the sense of presence, building on interoception and bodily self-awareness within the free energy principle in order to explain something about your kind of deep aspects of consciousness, and then this whole cybernetics perspective that lies behind it, which I think is really interesting. What I'll do in the last 5 minutes here is to try to go deeper into some philosophical areas that we're working with in my group with my collaborators, and that's partly to self-promote, obviously, but also to kind of present it as an invitation to really employ the prediction and minimization framework in whatever area of consciousness science interests you, and it's often quite fruitful. Sometimes it's a bit too easy as well. So the first theme here, there are 4 themes that we can talk about. The first theme has to do with the body image, and on a perceptual inference framework. Like the prediction and minimization scheme, your body image is really a representation that's subject to prediction and minimization. And if we clamp down and do not allow you to act, we don't allow you to act to test your hypotheses, then your body image will be hostage to your current prediction and minimization possibilities. And Neil talked about this yesterday in terms of the rubber hand illusion. I think it explains the rubber hand illusion. And it's philosophically interesting because it reveals a kind of perceptual fragility. If something happens with your opportunities for engaging actively with your world in order to test your hypothesis about it, then you might be quickly thrown off the otherwise robust world picture that you have. And we've showed this in the rubber hand illusion, where we can quite quickly put you in the rubber hand illusion and then within that give you an illusion of supernatural events, such as invisible rays touching your hand, or a big needle threading your body, or giant spiders attacking you. And they seem very, very real. It's a very immersive virtual reality that we can put you in. And we think that has to do with your ability for minimizing prediction error in situations where action is curtailed. And then behind this idea of the body image are questions about what the self is. And there's a surprising number of people now thinking that the prediction error minimization scheme can tell us something about the self. And our line is that the self is real. They're causes of your sensory input, just like any other cause of your sensory input is real, by and large. The self is the set of endogenous causes of sensory input that you receive. So you act in the world that reveals something to you about these hidden causes, and you therefore infer what your self is. So your self is inferred in this sense. The second theme that we've been looking at has to do with attention and consciousness, and we heard a little bit about this already. The question in consciousness science is, well, are these necessarily related? Do you need attention in order to be conscious, or are they dissociable? Can you be conscious without attention? And I think that the PEM framework delivers a really neat way of understanding attention, namely as your attempt at optimizing the precision of your prediction errors. And this means that we can relate attention and consciousness in a way that takes care of all of the empirical evidence as moments of different moments of sufficient statistics, the mean and the variance. This then in turn relates to our understanding of action in a quite interesting way, at least for philosophers. So on this account, action initiation, so this comes from Fristen's, Carl Fristen's overall framework. Action initiation is driven by expected precisions. But that means that acting in the world becomes an attentional phenomenon. And that really screws with our normal notion of what action is. We don't think that action is just a way of allocating attention, but it is in this framework. So it's slightly revisionary. This can be used to furnish a new explanation of why we can't tickle ourselves, which we tested in various fun ways in the lab, in kind of small-scale studies, but we can make you swap bodies with someone else, and then we can show that you still can't tickle yourself. Okay, 2 more. We've also looked at something we all know, which is the kind of temporal sense of flow of our conscious stream. This is something that's quite difficult to explain because it's not just tied to the flow of causes out in the environment. We know that because it happens when we're dreaming, for instance. It happens like in binocular rivalry, when there's no change in the external world and yet we impose a flow from between the two gratings, for instance. We've tried to explain that as a kind of probabilistic distrust of the current prediction resolution. The world is a changing place, and we've learned that over time. So as soon as we settle on a particular hypothesis that allows us to explain away our sensory input, we start distrusting that hypothesis. We start assuming that something will happen behind the scenes such that that hypothesis will soon be obsolete, so we start giving it up and looking ahead at the next one, and that kind of forces us forwards in the flow of time. This, to us, explains binocular rivalry, not as a visual phenomenon, but really as a temporal illusion that again speaks to the fragility that we talked about before. So the brain says, well, I can't deal with these two different inputs. I can't fit them into space next to each other. So I'm just going to assume that they're flipping over in time. They're succeeding one another in time. So we create this temporal flow where there is none, which is really an amazing illusion if you think about it. Now, these ideas about distrusting the present and knowing that the world is a changing place and the rate with which the world is changing then plays into a family of theories about autism. One theory here is that autism has to do with increased precision of the prediction errors. We think that it's slightly more subtle than that. It's a deficit in fitting your overall model, not of the world, but of the variability of the world. So in essence, or in a slogan, in autism, some parts of autism can be explained by people trusting the present a bit too much. They're kind of stuck a little bit too much in the present. Hence, binocular rivalry is a bit sluggish in autism, studies show. Here's the last topic. So at a very grand scale in cognitive science and philosophy of mind, there's been a lot of debate about the embodied mind, extended mind, situated cognition, those kinds of things, inactive cognition. I think that if you buy into the prediction and minimization scheme, you get a very old-fashioned, old-school, orthodox view. This is based on the idea that if the prediction and minimization scheme is correct, then the brain should be seen as a kind of self-evidencing organ. The brain does all of action, attention, learning, and perception behind a sensory veil. So in principle, you can understand everything the brain does by throwing away the world and the body. And this is very much in opposition to embodied cognition movements around the world. And it's controversial as well. So Andy Clark, who's also buying in heavily to the prediction and minimization scheme, says, no, there's no impermeable veil. We need to keep the world and the body in order to understand anything. So there's an ongoing debate going on there. Okay. In terms of the overall structure of the talk so far, we can do it in terms of the neural correlates of consciousness. So one way of phrasing that is, as we saw, just find the minimally sufficient neural process for content in a global state. Then we made the move that maybe we should look for the minimally sufficient neural prediction or minimization process that's enough for a content in a global state. And then the second level is to say, well, let's just divide and conquer between the different roads to consciousness. Take what's best from each, see how it fits on to the prediction and minimization scheme, and then deliver that way, maybe, an overall prediction and minimization theory of consciousness. And that way we might get, as Dave said some years ago, much greater potential explanatory and predictive power. So thank you.
Thank you very much for that fantastic synthesis. Maybe we could have the lights up now and our other speakers up here. Please, Jakob. If there are speakers from yesterday that are here, I was going to encourage you to come up and ask questions, but we have 5 rows, 5 chairs, and we might have to get another one. So I would ask people who are at the mics to please be clear, speak into the microphone, please be concise. I don't want to impede discourse, but let's try not to get involved in extensive debates so we could be respectful of our colleagues. So,
Yeah.
great. We've got Stuart and Anil. I don't know if Stan is here, but at any rate, please, we can start here.
Question for Richard. Your higher order consciousness, is it correlated to witnessing?
Is it correlated to
Witnessing.
witnessing? Oh, sorry. What do you mean by witnessing?
Well, like Vipassana, where you're self-aware and you're watching everything, all phenomena in a state of self-awareness.
In a sense, I would say maybe it's related to that. So the kind of awareness that I'm thinking of isn't explicitly self-awareness, since we would understand that to sort of be a conscious kind of experience. So the kind of awareness we're talking about is not self-conscious in the sense of you being aware of it. So I think maybe it's related to the idea of witnessing, but it might be slightly different in that we're not saying that this is kind of, you're aware of the fact that you're witnessing.
Thank you.
Over here.
Hey, yeah, I would like to know what integrated information theory has to say about the combination problem or phenomenal binding. Basically, I mean, I understand that it's taken as axiomatic that consciousness is integrated and unitary, which I think it's true, but the question is, what is the mechanism of action? I mean, just looking at, from a third-person point of view, all these pieces of information are integrated, doesn't imply that they are ontologically integrated in and of themselves.
Yeah, so that's a great question, and I didn't actually explain much about the exclusion principle, and that basically deals with that. And also, it is the most difficult part to empirically test, actually. But what basically it means is that over the spatial extent of the brain, and also temporal degree, like Jakob actually mentioned at the middle of his talk, IIT claims that it is the local maxima of the system, which IIT calls it as a complex, is the only thing that matters for consciousness. So in the case of human brain, subset of the brain, neural mechanism actually achieves this maximum level of the integrated information, and within that, if you compute a phi within that subset, then that corresponds to contents of consciousness. But outside of it, like including a cerebellum or anything that happens in the liver and things like that, that are not part of the main consciousness. And that should apply to artificial systems or paramecium or something like that.
Thank you.
I also have a question about IIT. So if I understand correctly, when it comes to the state of consciousness, you approximate phi using PCI, right? And then depending on the value of the PCI, you categorize vegetative state or conscious state or other states. So first, where do you draw that threshold? I mean, given the fact that conscious experience is all or nothing, where would you actually draw the line for, okay, above that line is conscious, and would that line be specific for one subject, or would it be consistent across different subjects?
Okay, so first of all, PCI is really coarse and approximate, empirical, clinically, validatable sort of, concept. And it's actually, if you really think about it, it's nothing to do with the integrated information, in my opinion. It doesn't become zero even if you apply it to the dead brain, because you can apply to apply the brain, dead brain TMS, and then measure some kind of spread, and then you can compute zero, more than zero value of the, PCI. So it is a good, approximation of simultaneously capturing integration and information, but you shouldn't really take it as seriously.
You can answer the question for phi equally, equally validly. So if you were able to compute phi, where would you draw the line saying, okay, above this phi is conscious and below is not,
okay,
and would
so
it be specific for subjects or general?
In original theory, so it doesn't have any boundary. So IIT actually repeatedly claims that it is a graded thing, but under the, this grade there is some kind of sort of sigmoidal curve, maybe some kind of transition that happens at some certain level of the phi or something like that. And then from that, you can become conscious of many things, and also, can be, aware of themselves and things like that. And that transition may be the one that you might want to actually call it as conscious. But according to Phi, even some, stupid system like 2 photodiode, it's not zero, but it's a different things.
Okay, over here, sir.
This one is for Richard. Hello. Richard Brown? Yeah. Hi. It seems to me I've never had a thought of the form, I am vividly aware of something at a certain location in my brain or whatever, all right? So, in other words, it seems implausible that, if there's going to be a higher thought theory, that there would be nothing about the content of what I'm vividly aware of in my higher order thought. But if you're kind of nodding sympathetically, I take it.
That's just what I do.
But in that case, I think you have a false thought problem, all right? So I just want you to say a little more. For example, if I have a higher order thought that, has something about the content, but there is no first level state, would I notice, would that be just like being conscious in the ordinary way of a first level state or not?
Yeah, thank you for that. So one thing I will say is that at least on the version of the view that Hohwy and I have been working on, the sort of higher order joint determination view, which was, he was talking about the higher order certainty index, which is an older name for it. But anyway, so on that view, the idea is not supposed to be that these kinds of higher order thoughts are ordinary thoughts. In fact, we sort of think that there would be a specialized module in the brain which may be in the business of having these kinds of thoughts. So we wouldn't expect that you would have them as part of your day-to-day normal thinking course. So that would be one thing. So I do think that traditionally, though, higher order theorists sort of say, yeah, it's just the same kind of thing that you have when you're thinking about lunch or something like that. And we want to say, no, this is a more specialized process in the brain whose sole purpose is sort of judging the reliability of the incoming signals, trying to make sense of whether or not it's noise or whether or not it's an accurate perception or something like that. So it's not just normal kind of thought. On the false thought thing, then I would say, well, yeah, we very explicitly endorse that, at least on that version of the view, that there would be some kind of conscious experience in the case of a missing first order state, but that it wouldn't be, so you would have the experience of vividly perceiving something, but not any particular thing. And that's a very strange thing, but we think that there are actually empirical reasons to believe that people do have those kinds of experiences, as for instance in the partial report superiority kinds of cases where you flash a grid and you ask people to name the letters and they feel very confident that they saw all of them but can't name all of them. So we think, well, this is sort of an account of how that could happen. Why do you feel so confident that you saw all this stuff? Well, because there's a higher order process saying that this is, you have some vivid content down there, but then when you try to say what it is, you can't do it. Now, there are other ways of making sense of that kind of data, I think, but this is one way of interpreting those kinds of results, which doesn't make it paradoxical or strange.
Dwight,
Richard Brown again, sorry.
can you speak right into the mic?
Richard Brown, if I can ask a little more about the first, the direct acquaintance. I don't know if to use the word witnessing, but from what you mentioned Chalmers, and perhaps you could just, one thing, just mention what the source is, the recent source, because I'm familiar with TIE on direct acquaintance. My question is, what is your basic critique of direct acquaintance? What is it exactly? In other words, it's not just a response to visual stimuli, it's a knowing, but yet it's not self-conscious. So that's rather getting subtle. And you're saying, I guess your critique is that we need, for this knowing, that it's more than just a responding, we need this higher order mental approach. Is it possible the direct acquaintance knowing is not coming from us, but actually coming from outside to us? And I don't know if any of these direct acquaintance supporters take that position, TIE or Chalmers, but maybe you could just remind us what their point is, how much is contained in this direct acquaintance, and what your critique of it is, And again, the Chalmers citation. Thanks.
Okay, yeah, thank you for that. So the Chalmers citation was from a 2011 symposium on his book, The Contents of Consciousness, which was published in Analysis. And so Susanna Siegel, Benj Hiley, and I'm blanking on who the third person was, Chris Peacock, they commented on his book, and then he responded to the commentary. So that's where that comes from. So the idea of acquaintance, so this is inspired by some comments that Russell made. So Russell, I think, is maybe the person who introduced this into the literature, although maybe I shouldn't have said that because I'm not sure. But the idea is supposed to be that it's a kind of knowing that doesn't involve an intermediary, so that there is no conceptual layer in between you and the thing that you're acquainted with. It's just there it is. So my critique of that wasn't really a critique. It was more just of a worry, which was that if you take that sort of view, then you've given up trying to explain how the redness of my phenomenally conscious experience comes to be the way that it is. You're saying it's that way already, and then I just kind of get to know it. And that seems to me to sort of then give up on what we were trying to do, which is explain how the consciousness arises, and in particular the properties of conscious experience, how those things arise. So that's my worry about it. It's not so much of a critique, though.
Over here.
This is for Dr. Tsuchiya. Suppose that I have an integrated sorcery theory of demon summoning, and that I have a team of psychics and mathematicians who are able to formalize some intuitions we have that we call axioms for demon summoning. And so the mathematicians from these postulates are able to formalize, a set of formulas that we're able to have for the size of a circle for summoning a demon, the number of us, psychics to have, and so on, for an arbitrary number of features. And we are able to specify what sort of demon and how we might expect this demon to be summoned. The problem with this is that demons aren't really perceptible, and that we might say they're private. To know that a demon is there, a person might have to just have this sense of this evil presence being in the room, but otherwise no one would be able to verify another person's perception of a demon.
Sorry, because of the mic, maybe I really couldn't understand what you were saying.
Very difficult to hear. Could you just ask a specific question?
Okay. To skip the analogy, so what would it take for the integrated information theorist to falsify his own theory?
Oh, it's very easy. If you find some kind of conscious perception or a conscious being, which has, no integrated information, then that's it.
Absolutely, but under what criteria would you judge that such a conscious person or conscious being be conscious?
What kind of theory would you judge that they don't?
That depends on, the, IIT itself, right?
Right, but there are very unambiguous targets for judging the consciousness of a thing. For instance, for people, right, this is very unambiguous. For the cerebellum, it's very unambiguous. For a banana, it's relatively unambiguous.
Okay, so how do you sort of gradually make the theory trustable or testable, right?
Right, it's really important for the ambiguous.
Okay, in that sense, then I think that's the thing that is very different from pure mathematical theory. The IIT always starts from phenomenology.
Right.
So ultimately, what you can actually test or verify is your own phenomenology. And that's why it usually starts from conscious and non-conscious states during a dream or a sleep and things like that. But about contents of consciousness, we can probably test and confirm some of the prediction in the future. Like if you implant some artificial neuronal circuit, and according to IIT, you might be able to make some kind of specific prediction of what kind of additional sense you will have if you attach it. And then if you attach it, and then according to IIT, it should give you this kind of echolocation sensation, or you will lose color, but you will get additional sense of depth or whatever. That you can actually verify by yourself, and that's the ultimate test of the IIT.
Okay, so you would be able to verify.
We're gonna have to move on. You can talk to him afterwards. Thank you, sir.
Yeah, this question for Jacob. I was really fascinated by the perceptual fragility of body image. And I'm wondering if you have anything to say with it giving out-of-body experiences. And I'll tell you why I'm asking. I had a friend who was, who for a few days slept on a mattress on the floor, and every night he felt that he was rising up in the air, and finally found that there was a spring sticking out that I'm guessing was anesthetizing some of his nerves in the back, and that was enough to give an out-of-the-body experience.
Okay, there's a great case there of changing the prediction error landscape and thereby constraining something very fundamental to your sense of being. And people who are involved in the rubber hand stuff and the full body illusion stuff are also interested, like Olaf Blanke and Thomas Metzinger and others, interested in out-of-body experiences. And some of the theories that are yet to be kind of confirmed or tested fully play around with those kinds of ideas as well. And the idea is that when you sleep, your head position might be such that the others in the inner ear give you conflicting signals that might conflict with your dream state and so on, that then convinces you that you're actually leaving your body behind, or that you are both moving and standing still at the same time. And then one solution to that, given other kinds of cues perhaps, is that you've left your body behind. So it's an area that is actually being researched quite extensively now, and the framework for prediction and minimization gives a good case. In your case, it's nice, right? Because if you've blocked some of the input that you normally have, or maybe immobilized you in some way, then you can't test the hypothesis that you've hit on, and then you stick with that.
Rocco?
Can I make a quick follow-up to that? I think that example of out-of-body experience is very important because it highlights a case where you might think that, say, some scientists would say, no, science shows out-of-body experiences don't happen because the mechanisms of consciousness are in the brain or the body or somewhere. Whereas other people might say, well, no, I've had them and they happen, and therefore science can't explain consciousness. And this is a false opposition. It's certainly true that people have out-of-body experiences and near-death experiences and other sorts of very unusual phenomena. It's certainly true that those experiences exist, but that doesn't mean that the sort of natural, intuitive accounts of why those experiences happen need to be correct in terms of the locus of consciousness being able to leave the body and float up to the ceiling and whatnot. So there's an opportunity here as well, which is for consciousness scientists to take more seriously phenomenological reports of unusual experiences, but try to come up with non-mysterious accounts of them.
This is for Richard, as you might guess. Rich, on standard, for example, on standard hot theory, as you know, and even many variations, the higher order thought is...
Could you speak a little bit closer to the mic?
Sure. On standard hot theory, even on some variations of it, the higher order thought is, of course, meant to be, or at least traditionally meant to be, itself unconscious, right? So when you were talking about how, to what extent your view might differ from standard hot theory, when you describe what happens in cases like the empty hot kind of case, or when you say there's something like subjective character going on at that level, maybe more like Uriah's view, are you then giving up the idea that the higher order thought is typically unconscious when we have outer directed mental states, conscious states? And if so, isn't part of the original motivation for the theory that it could be reductionistic in a certain way, sort of abandoned as well?
Well, thank you for that, Rocco. Yeah, no, I'm not giving up on that. So I was answering the other question about witnessing. I was trying to invoke this distinction. What I think is that the word consciousness is multiply ambiguous, and so we have to distinguish the senses here. So on the one hand, there's the notion of state consciousness, which is simply the idea that there's a higher order state which is targeting or describing a first order state. And in that sense, on the horror theory, the state is unconscious because there is no state which is targeting it or representing it. On the other hand, then I would want to say, but that's different than phenomenal consciousness. Phenomenal consciousness is not a matter of representing a state, but a matter of there being something that it's like for you. And in that case, the higher order state is phenomenally conscious, but not state conscious. So I think if you separate those two, then you preserve the idea that, yes, there is no awareness of the higher order state, but that's what phenomenal consciousness is.
Wolfgang?
Hello. I'd like to ask you about relationship between prediction error minimization and surprise. So let's say you decide that you want to engage in an activity in which you want to be surprised. Yeah, it's for Anil or Jakob. I think. Let's say some improvisation activity, or watching a movie, or it could be something like very, very common. Would that correspond? I don't know what. I would like to know what your thoughts are on that. Whether that corresponds to, I don't know, setting an intention of allowing a larger prediction error, because if there's a low prediction error, you won't be experiencing surprise. But if you want to do that, so. Yeah.
I'm not sure I quite get it. I mean, the thing is, everything is surprising in experience. Every sensory input that we get, even if it's a self-generated sensory input, is somehow surprising given our expectations. And my view is that this continuous stream of sensation and action depends on the brain expecting a certain degree of surprise. So it's not that we just settle into a state where prediction error is minimized and then that's that. Even in a movie that there's sort of long timescale predictions structured by the narrative of the movie. The moment-to-moment change in visual information is still going to be somewhat surprising. So there's always something to be minimized. There's always some way in which your inferences about the world are going to change. And of course, because we act and we do things in the world, that's all about making predictions about our own bodies and where they're going to be in space. So I'm not sure if that addresses what you're saying at all, because I didn't quite get the question.
All right.
Maybe, yeah.
So I agree with that. But also, there's some nice work being done now within the kind of prediction and minimization research groups around the world in terms of the exploration, exploitation distinction. And this relates to what I mentioned about the fact that we're living in a changing world. So we constantly have to look ahead to the next hypothesis under which we minimize prediction error. And sometimes we don't know what the best next hypothesis is going to be. And this relates also to the time scales. We don't know, we might know it in terms of kind of very short time scale, but what's the next big hypothesis about, how are we going to get dinner tonight and those kinds of things. And sometimes you just have to increase prediction error in the hope of finding precise prediction error for you to minimize at a certain time scale. So I'm sure we're all going to do this in a very short while. We're going to walk around aimlessly trying to find some food. Well, I don't know where to find it in this complex, but we will eventually succeed. So that's exploration and exploitation.
Sir, thank you.
Yes, I have one question about IIT. And the question is, as I understand it, you can mathematically compute phi and correlate that with a perceptual experience. For instance, the subject says they see the face or they don't see the face, and then you said you could do something similar with a bat and see if echolocation is like auditory or visual perception. How do you get the bat to tell you what it experiences?
It's a bit different. The way I presented the work may be a bit misleading, but what I wanted to try was if you repeat that kind of experiment, a correlation between what subject perceived and generated structure of the phi, and then we can repeat that within the visual modality and also auditory modality, and because phenomenal structure of the vision and the audition is so different, at least for me. There should be something that explains this vast difference between vision and audition. So the constructed shape could be that, in the case of the vision, it is always it has some structure that preserves this two-dimensional aspect of the vision, and the fact that, no two objects is in the same location, and things like that. That's the kind of the phenomenal character of the space, and which should be reflected into that, phi patterns. On the other hand, if you construct the phi patterns from the auditory cortex, then auditory perception, I'm not an expert, but different melody, but within pitch sound feels the same way in somewhat, a sort of cyclical kind of structure. If you play piano, you repeat the same kind of structure every 8 or 7 notes, right? And that is sort of the cyclical kind of structure of the audition. And so because of that, I expect that if you produce a pattern, a phi pattern based on the auditory cortex, then you should find some kind of a pattern that corresponds to that phenomenal structure. And once we get that in humans as well as animals and so on, as well as also, I would say, rewired animal, but I can't talk about it today. Then, after that, if you reconstruct bats, echolocation cortex phi pattern, which that phi pattern could be similar to visual or auditory.
Yeah, but how do you get the bat to tell you whether it's echolocating? He didn't answer my question. How do you get the bat to tell you whether and what it is echolocating?
No, you don't need bat's report.
I think you're going to have to discuss after. We really only have time for one more question. Or two, because I think they both got up at the same time. So these two gentlemen at the mic, and then we're going to have to cut it off.
I have a question about the relationship between integrated information theory and ORC-OR. So I want to know if these two theories are consistent with each other. So imagine that we found that all of the integrated information is in the processes and microtubules that Stuart says is the nature of consciousness, we define consciousness. What would that mean? Would that just mean that the two theories are consistent with each other? Or would it mean that there's something missing about integrated information theory, that it's kind of ignored the biology? Or would it mean that ORC-OR has put too much emphasis on the biology and not enough emphasis on this abstract structure? So what would it mean if we discovered that?
Thank you for that, Kelvin. Well, first of all, as you point out, there's more integration happens, first of all, in dendrites, not axons. And in the dendrites and the microtubules, there's a lot more integration that happens at the higher up levels because it's more condensed, it's denser down there. So there's way more integration. So if IIT is true, it's most likely going to be in the microtubules. Then you might say, as you have said, well, that proves IIT, but it's just happening in microtubules. But in our view, the integration culminates in a collapse in a quantum mechanism, which ties to the hard problem, attempts to solve the hard problem. That raises a couple other issues. I want to go back to a question about out-of-body experiences. I don't know if that actually happens, but there's plenty of evidence for non-locality in consciousness in terms of psi, in terms of backward time effects, which imply quantum effects. And also, anesthesia works at the quantum level. But in answer to your question, I think there is integration in the microtubules underlying and it's also doing error minimization, predictive coding. So as I said yesterday, it underlies all of the other models, in my opinion.
And, I'm sorry, did you want to comment as well?
So my short answer is that it's possible that both are actually consistent, but highly unlikely, I would say. The reason is, as I mentioned to the question, in the first question, IIT maintains it is the exclusion principle that, exclude not all the level of the processing that matters. Like, in the Jakob's presentation, we can possibly, change the quantum states or, molecular states or, even ion channel or, something much more than, molecule. And even actually single neurons firing or not, that doesn't change the conscious states or conscious percept. But IIT would predict that there is some certain level of the neuronal population. Most likely it's the microcolumns or maybe some subpopulation of the neurons that has the really strong causal power that attains the highest integrated information. And that, if that is already there, no matter what you actually change in the really low level, it shouldn't change the conscious person. That's the prediction, but it's an empirical question.
Last question.
Great. I just wanted to ask a question about IIT, about an objection that I don't think you mentioned, which is Scott Aronson's objection that it would impute huge amounts of consciousness to physical systems that don't do anything but apply transformations to a matrix. So I'm thinking about Scott Aronson's expander. As I understand it, Tononi's reply is just to embrace that conclusion. I was wondering if you had a different take on that. And yeah, I know you mentioned the distance conception of phi, does that affect how you think of the expander?
Okay, so as to Scott Aronson's argument, my answer is also pretty much identical to Julio's. But what hasn't been emphasized in IIT papers so far is that it is the theory about quality of consciousness, contents of consciousness. So and actually Tononi himself wrote that in 2009 or something. If you actually have a grid of the structure, then it has a really huge amount of phi, but it doesn't probably feel much actually because there is no interesting kind of the structure that emerging. So if what I did for the face perception case is actually turned to be true at even the level of the neurons, then that kind of structure should preserve some kind of phenomenal structure about the faceness. But expand the graph or just a 2D grids, infinite grid, that may actually create huge space of some kind of conscious field, but there can be no concept, no color, no position, whatever. It doesn't probably feel much. That's the prediction.
Okay, thank you to our speakers. Thank you to the audience.